professor of mechanical engineering here. Been here for 15 years or so. Was chair at one time, dean at one time, and was in the Senate working for Senator Feinstein for a year. So I've kind of been off and on around. Just got back from a trip to Australia and Stockholm. So occasionally some of these trips come up and I'll just have to be gone. And that's one of the reasons why I wanted to try to get this course up as much as I can electronically. When I'm not here, I'll have somebody sub for me, probably Dr. Long will substitute for me as far as the lecture. Sometimes the lecture will be very short. And what I'll say is, okay, just go to the website, look at the slides. There may be enough information for you there. If not, then you just contact me or come by my office or send me an email. Okay, the book, if you don't know already, is the one by Chapra and Canale. So it's Numerical Methods, the 5th edition. And I was over at the bookstore yesterday, and I know that they have it. There's several versions of that book out, including a very condensed version that was put out by Chapra that's basically more MATLAB than anything else, but it doesn't have enough material as far as the completeness of the numerical methods. So that's what I like about this textbook, is that it's pretty complete. And there's some methods in there that you'll probably never use, and there will be some that you may use later, but we may not have time to introduce to any extent here in this course. But you'll find that it's a very good reference. Now, as far as the syllabus, if you take a look, I've broken it down in the lectures as far as the Tuesdays and Thursdays that we meet. You'll see that the topics, the introduction and review, we'll be doing that this week. Then we'll get into roots of equations, systems of equations, interpolating polynomials, some of these things that we'll pick up later on, differentiation, and then ordinary differential equations. I assume everyone has been through 3 semesters of calculus and a semester of ODEs. Everyone's in a grade 1, believe it or not. There'll be somebody that's in here that hasn't had that. And then they'll start asking questions like, what's that factor of 6 mean, or something like that. So, what's the big S? And so then you know you've got some trouble. Now over to the right, you'll see that I've got the homework and the programs. So what you'll be doing is a problem that I'll give you that will then be due every 2 weeks. You notice that as we get on later into the course, particularly towards the end, we'll look a little bit at statistics. Last year I had the class do a Monte Carlo simulation. We may try to do some variation on that this time. I think you'll find it's an interesting tool to have. And to say that, yeah, you've been able to do those kinds of simulations will be valuable in wherever you work later on. You notice there are 2 exams and then a final. Also, after Thanksgiving, we'll get into partial differential equations. These are actually the PDEs. That's what you'll be doing primarily in your work outside, or if you go on to grad school or whatever, is solving partial differential equations. And there are a number of techniques that you need to be familiar with as far as how to do those. And we'll talk about some of those at that point. We'll wrap up in the final and then we're done. Now, as far as the problems themselves, notice that I have listed Fortran as a language, C, C++. Also have Java. For those of you who want to program in Java, you can do that. MathCAD, MATLAB, or Maple, or even Mathematica. It doesn't matter. I don't care what you use here, other than you have to write something that's going to use the computer to solve the problem. Most of the problems that I give you may have an analytical solution, right? I mean, you can look at it from inspection like, oh, I know what this is supposed to look like. So when you run the program and it doesn't look right, then you know, I guess I got something wrong with the program. So you can take a look and try to fix it. With regards to the course grade, the 2 exams, each will run 25%. The final 30% homework will run 20%. All right, now I mentioned the programming tools before. For those of you that have Fortran, what Fortran version are you using?
This is a few years ago, I don't use it anymore.
78, okay. So, well, it depends on if you want to program with it. You really don't have to, but if you want to. There are a number of copies of Fortran floating around here, including those on the PC lab, the PCs upstairs, that you could actually get onto and compile a code and then run it. So inclined. MATLAB, MathCAD, most of you, how many of you have had exposure to MathCAD? Oh, okay, so you've seen it somewhere. The Maple, I can work a deal for you through Maple. They've actually allowed me to set up something for you that if you want to buy Maple, how many of you know what Maple is? Okay, so it's very good mathematical, kind of like Mathematica, the equivalent of Mathematica. It's a very good program solving mathematical equations. I can get that to you for $79. That's a very expensive package if you try to do it on the outside, not as a student here. So, but if you're interested, let me know. And I can actually set up the website for you. And the fact that you're taking this course, they will then say, oh, good, I can give you a student break on this. There is Mathematica available. The mathematicians here generally tend to use Mathematica, so there's a license that's floating around somewhere, probably on campus if you're so inclined that you want to use it. And of course Java. Anybody do anything in Java? You know what Java is? As far as like an extended C, C++, the right things, and it's interactive on the web. The principal guy that's really good in this is Lect1. He's in computer science, so any programming language problems that you might have, I suggest that you just make an appointment and go see Lect1.
You had mentioned MCMPX.
I didn't mention that. Do you want to do that?
No, you had said that we might have been doing Monte Carlo.
Oh, you mean, yes, yeah. Last year I gave the class a Monte Carlo problem. All right, and I may do that again this time. It depends on how well we're doing and tracking at that point. But it's a problem that will require you to do some sort of Monte Carlo statistical simulation. It means running a lot of do loops and so forth, or simulations. Now, some useful references that you may find helpful to you. Numerical recipes. This is available in the library, and it has been a series of books that have been around for a long time, put out by Cambridge University Press. And in there are all the algorithms, all the codes, all the techniques that you would ever want. And they're written in various languages, from Fortran, C, Java, whatever. And so you can, there are usually several volumes. And there are source codes available as well, so you can actually download those codes, and then from that you can tweak them and modify them as you want. Those are very, very good. Also, MATLAB, an introduction with applications. I'm sure that most of you probably have some reference or some book that you've used with regards to MATLAB in the past. You might want to dust that off and take a look. Usually, the class tends to migrate towards MATLAB, at least the majority of the students. And it's just that they're more convenient and familiar with it than some of the other raw type languages. This is an example of programming for an Euler ordinary differential equation using MATLAB. As you can see, it's relatively simple. It's very, very efficient. It takes only a few lines of code. You're actually calling up kernels, that is, programs or subroutines that are embedded within MATLAB that make it very easy to solve these kinds of problems. This is what it would look like if you wanted to use Maple. And so while Maple is a very powerful package, it turns out that it takes a few more lines of coding to actually go through it, to set up a program to use Maple in this sense. Now, if you go to Fortran, the reason I include Fortran here is that when you get into upper level type of courses or in advanced courses, or certainly when you get out in industry, you're going to run into Fortran codes. And it's just that they've been around for so long, they don't throw them away. You're going to have to wind up at some point trying to figure out what it is that's going on within this Fortran code. Now, it used to be that we required a programming language here, and that language was Fortran, and you had to take a course in it. Well, they did away with that some years ago, so you're kind of on your own. So at some point, you may have to pick this up. Just a word to the wise, particularly depending on where you're going in industry later, that you may wind up inheriting some of these Fortran codes, and it would be a good idea to sort of know what's going on. This is that same thing, solving an Euler ODE, and this is what it takes as far as the programming language and the number of lines of code. You can see that things are broken down into subroutines, and usually it turns out to be much easier in setting up an overall program when you do things in subroutines and breaking it up into these subpackets. As you can see, the amount of programming can be fairly long. Now, if you're interested in any of those languages, then come to see me. And I can at least give you some hints, clues, or ideas, or at least I can tell you who to go see with regards to some expertise in those languages. All right, now, any questions from you?
How does
Okay.
this going to be?
How are the tests, in what regard? Like hard, easy, or?
Oh, like, are you going to ask to do like a program on there?
Okay, good question in the sense of what's expected. I can't have you write a code in an exam because it takes a long time. As you will discover when you start doing these assignments that, gee, you got to kind of work at it over 2 weeks. You know, sometimes they're really easy, sometimes they're not. So during an exam, I may say, what is the recursion relation for solving an Euler ordinary differential equation? So a recursion equation is like an algorithm. So here's the governing equation. And then what I'm going to do is write that in a numerical approximation that will permit me to then solve them. All right? So that's what I'm after. Okay? Sometimes it might be a definition. Sometimes I may say, okay, work this out by hand using, say, 3 steps of a simple technique that now you're the computer. But I know it's a simple series of operations that you can do, you know, to show how this thing might work.
Another practice would be like, we understand how to do the whole project, the first day you assign it, or we not really understand how to do the whole project the day you just do.
No. What's going to happen is that I'll give you an assignment. I'll say, okay, this is due 2 weeks from now. And during those 2 weeks, we will go over what it is and some techniques that you should be using. Now, that doesn't mean, gee, you have to wait until the night before you can solve it. Usually in the problems that I give you, you'll be able to start working on it almost immediately. Okay? So no, I wouldn't put you in a box like that. Okay, any other questions? How many of you have gotten the textbook? Okay, what's it going for?
A lot.
Too much.
140, I think. 150.
Yeah, you're going to. The point is that you'll need it for this class, but you're really going to need it later on because it will serve as a reference book for you when you get into other higher level courses where it's going to say like, give me a finite element approximation for this. And so you're going to go, how do I do that? So you go back into this textbook and he's got everything laid out for you as to what you need. Any other questions? So we'll really start formally on Thursday, and I may have a short lecture again. It just depends, but every once in a while we'll get a lecture, pretty long. And sometimes I'll be going through these things, and it's like, is this ever going to end? Don't forget that we will roll these things up onto a website. Now I know that the WebCT has changed. We got to figure out what it's changed to.
Webcam.
What's going to do that?
Webcam.
Has anybody used the latest whatever it is?
Yeah.
Okay.
over the summer.
How is it?
It's almost the same thing, it's just a different server, different base, a couple different menus, but it's the same.
Oh, okay, so no surprise it was ours.
I think the right class.
Okay. Yes, sir. I want you guys to come down to my office. And I'll give you a copy. I think this class started out at 22 and it's 29 now.
Explode. How's it going? How was your summer? Oh, did you?
By the way,
Cool.
Does everybody know what this is? This is the Nevada Center for Advanced Computational Methods. The center I started 10 years ago, and it's where we develop a lot of advanced algorithms and techniques. And so there's a resource of 20-some people that you can actually go to if I'm not around or you're desperate to find out something about a particular method. That's what this center does. Solves a lot of PET type problems. Okay, thanks very much.